Welcome to Lesson 4, an intro to GenAI. We will be diving into something really cool, how ChatGPT, a type of generative AI, really works. You've probably seen it answer questions, write stories, and even do your homework. But how does it actually work? Before we talk about ChatGPT, let's zoom out for a bit. ChatGPT is part of something called generative AI, a subset of AI that can generate or create its own original stuff. This could be anything from essays, painting pictures, or even making audio like music. Another important thing to note is that ChatGPT really refers to a collection of different machine learning models. However, for now, when I refer to ChatGPT, I will be talking specifically about the GPT-4o model, the one that most people have probably used and the default one that comes up when you go to chatgpt.com. So what happens when you use ChatGPT? Well, being a computer, it doesn't think in words like we do. When you enter something, it does several things to turn it into something it can understand. First, using a process called tokenization, and then something called embeddings, both of which we will talk about later in this video. Once your words are turned into these tokens and embeddings, they go into a machine learning model, the brain of the AI. This model does many calculations to figure out what the most likely next word should be based on the input and based on its previously learned knowledge. Then the response is built word by word until it's done. Now let's look closer at tokens and embeddings. Just like humans, the ChatGPT model breaks up your prompt into building blocks. These building blocks are usually what we think of as individual words, and in AI we call them tokens. In our example, you can see how our prompt would be broken down into tokens first, and then embeddings. But these tokens are still just words. So how does the AI actually understand them? Well, like how we store meanings of words in our brains, the AI stores meaning of words in something called embeddings. Embeddings are the mathematical representation of a word and is really a big vector, which is just a big list of numbers. A good way to visualize these is to think about each word being put in a 3D graph with more similar words closer to each other. In our example, words like France and Paris are near each other, while others like Germany and Berlin are too. In our head, countries and their capitals are usually related in some way. This is how the AI captures this. Here's a better example. You can see that the fruits, animals, and vehicles are all grouped next to each other, just like how we think of them. Keep in mind that these embeddings are really large dimensional objects, but to make it easier to visualize, we can compact them down to this 3D space without completely losing their meaning. Now that you know how ChatGPT models understand English words by converting them to embeddings, how does it actually think and generate a response? First, let's talk about encoders and decoders, something that will help us understand ChatGPT. Not surprisingly, it's partly based off how our brains work. You can think about it as this. If someone says the capital of France, you don't just hear sounds, you interpret it like, oh, they're asking for a fact about geography, specifically a capital. This is the encoder that understands what the input is asking. The embeddings we talked about before express meanings of individual words, while the encoder attempts to understand the sentence as a whole. Then, naturally, after understanding, your brain will use that meaning and search your memory to build an answer, leading you to say, it's Paris. This creating of an answer is the decoder part, which uses the meaning from the encoder to determine the words to output. Using math, the decoder calculates the probability of each possible next word and chooses the most likely one, step by step, to form the answer. And in this example, you can see that the input to the encoder is the capital of France is, and the encoder is actually getting the embeddings of that sentence, and then the encoder transforms it into some mathematical representation of the meaning, which gets put into the decoder, and then the decoder says Paris is the most likely one, which is correct. However, GPT models, like the one ChatGPT uses, does not use both encoders and decoders. Instead, it uses a decoder-only architecture, doing both steps in the decoder. This means the decoder step listens and talks at the same time. Think of it as encoder-decoder having two specialists, one who listens carefully and takes notes to fully understand your question, and another, a speaker, who looks at those notes and prepares the best answer, while the decoder only is like having one highly trained specialist who can both read your question and generate an answer on their own. Under the hood, the decoder pays attention to your words, figures out what's important, and transforms that understanding into predictions about the next word. Then it puts that predicted word at the end of the input to then find the next one, and then the next one, until it's outputted all the words in the response. Now we know how ChatGPT models take your input and generate a response, but how does it know the correct response to generate in the first place? Well, there are two steps of training that occur that teach models like GPT-4o. First, think of how babies first learn. They hear thousands of words from parents and people around them even before they fully understand them. Over time, they pick up patterns, how words go together and what things mean. This is equivalent to the first pre-training step of teaching machine learning models, like ChatGPT, in which the models listen from a massive amount of text, which usually comes from the internet, and practices predicting the next word and learns patterns of language on its own. Then, to describe the next step, think about how a child that already knows how to talk is corrected by their parents sometimes, saying, no, we say this word like this, or how teachers guide them to give better answers and explain things more clearly. In model training, this is called fine-tuning, and human trainers give feedback, thumbs up or thumbs down, showing the AI which answers are good and helpful and which ones are not. And once these two steps are done, you have a working generative AI model. However, like humans, it can also make mistakes, which is why new ones are always being trained to give better and better responses. I hope this video was helpful, and thank you for watching.